Hey everyone, welcome to the channel. Today we're diving into an important concept in chemistry, bond energy calculations. So, let's get started. What exactly is bond energy? Well, bond energy is the amount of energy required to break 1 mole of a bond in a molecule. It's measured in kilojoules per mole. Simply put, it's the energy you need to pull atoms apart, or conversely, the energy released when they come together to form a bond. Think of it like this. Stronger bonds need more energy to break, while weaker bonds need less. The bond energy gives us an insight into the strength of a bond. Now, why do we care about bond energy? Bond energy calculations allow us to predict whether a reaction will release energy, making it exothermic, or absorb energy, making it endothermic. This helps chemists understand how much energy is involved in chemical processes and whether a reaction is feasible. We need 436 kilojoules per mole of energy to break this bond and 243 kilojoules per mole to break this bond. Therefore, the total energy required to break these reactants is 679 kilojoules per mole. When new bonds form, 862 kilojoules per mole of energy is released. Now, look at the screen. Using this formula, we calculate the total change in energy for this reaction, which is minus 183 kilojoules per mole. The negative sign indicates that the formation of HCl is an exothermic reaction. Alright, let's dive into an example. Take a look at the combustion of methane. Here, we break 4 carbon-hydrogen bonds and 2 oxygen-oxygen bonds, and we form 2 carbon-oxygen bonds and 4 oxygen-hydrogen bonds. Each bond has a specific energy value, which you can see on the screen. Using these bond energy values, we can calculate the energy required to break all these bonds, and the energy released when the new bonds form. Let's calculate the energy needed to break all the bonds. We start with the carbon-hydrogen bonds. Each carbon-hydrogen bond requires 412 kilojoules per mole of energy to break. Since there are 4 carbon-hydrogen bonds, we need 1648 kilojoules per mole of energy to break them all. Similarly, each oxygen-oxygen bond requires 498 kilojoules per mole of energy to break. For 2 oxygen-oxygen bonds, we need 996 kilojoules per mole of energy. Therefore, the total energy required to break all the bonds in the reactants is the sum of these values, which is 2644 kilojoules per mole. Let's calculate the energy released when new bonds are formed. We start with the carbon-oxygen bonds. Each carbon-oxygen bond releases 799 kilojoules per mole of energy when formed. Since there are 2 carbon-oxygen bonds, a total of 1598 kilojoules per mole of energy is released. Similarly, each oxygen-hydrogen bond releases 463 kilojoules per mole of energy when formed. For 4 oxygen-hydrogen bonds, a total of 1852 kilojoules per mole of energy is released. Therefore, the total energy released when new bonds are formed is the sum of these values, which is 3450 kilojoules per mole. Finally, we find the overall energy change by subtracting the energy needed to break the bonds from the energy released when new bonds are formed, giving us minus 806 kilojoules per mole. Since delta H is negative, this shows that the combustion of methane is an exothermic reaction, releasing 806 kilojoules per mole of energy. Bond energy calculations help us understand the energy changes in chemical reactions. By finding the energy needed to break bonds and the energy released when new bonds form, we can see if a reaction absorbs or releases energy. Thanks for watching. If you found this video helpful, like and subscribe it. If you have any questions, leave them in the comments below. See you in the next video.